when I was invited to give this keynote, I was a bit in trouble because I'm sure that whatever clever things I can say about evaluation, somebody already said. So I actually tried to look at it from a different angle, and let's see if that's going to work. How do I change the slides? Okay, yeah, I think it works. Okay, so thank you for the nice presentation. As mentioned, I work for Shopify, not Spotify, but it seems to be a common mistake by now, where I'm a staff recommender engineer. I work with product recommendations on e-commerce websites. So while in my book, I'm very focused on Netflix, lately I'm more looking into e-commerce recommendations. I've been working as a data scientist forever. I think by now I've been working with machine learning the last 10 years. And I'm specialized in recommender systems. I wrote the book, not that book, I wrote that book. Those others, their books. And then I've been co-chair for 2019 and 20, done a lot of other stuff. So when you afterwards, you evaluate this keynote, keep in mind that I'm trying to ask questions. I'm not saying that evaluation as we do it is wrong. I'm just trying to have some other things that you can also think about when we talk about evaluation. And that's why it's maybe wrong to say the proper use of evaluation, but let's talk about it. That's where I will start. Then I'll ask the question, how do we actually understand if a recommender system works or not? And then talk a bit about causality of events. So where do we actually evaluate? Because evaluation is one thing, but it's actually a lot of different things depending on where you are in the world. So I want to just spend 2 minutes talking about how you do in business, or at least how I believe we should do in business and how you do it in academia. And then, so there's one of the things that is missing now is that I'm not going to talk about online testing or A/B testing or multi-arm bandits and so on, because I feel that this is more on the offline evaluation. And so when you train a model and you try and figure out whether it should work or not, then you do offline evaluation. And then when it actually is in production, you also do online, offline evaluation to keep monitoring the model. And then, but while often people talk about the current state of the art when they talk about metrics and evaluation of an article, basically what we want to know when we do evaluation of a model is just, should we put it in production or not? And that's actually the most important question. So whether, in the sense that you could even go as far as saying, as long as it beats random, as long as it beats popular products, then we're actually happy to see if it works, because the correlation between your offline metrics and your online metrics are often so confused that it's difficult. So you use it just to decide whether it should go into the queue of stuff that you want to do A/B testing on. Another thing that you have to wonder, or you have to worry about or consider, is that when you say that this model has a good evaluation, the metrics looks good, then there's always somebody who's not happy about it. So what do you actually do with those customers or users that will not get the recommendations that they want? Because you can say that, as a, depending on the metrics, of course, then there will always be a group that will be more happy, and then there will sadly be a group that is less happy. Is that something that is acceptable for this model before you put it into production? Because, as I, at least at Shopify, for us, we have more than 1 million merchants, and we can't just put a model into production and then consider what happened without considering what happens if it breaks for half of them. And then I also think it's very important to say that you can actually compare the metrics, the evaluation, because even if you just talk about different merchants, then one merchant's garbage could be, or one merchant's recommender garbage could be another merchant's recommender gold. So you can actually just say this model works great based on this article, because it depends a lot on what kind of domain you are in and what kind of signals that you're working with. To move on to I don't know if there is a better word for it. Maybe it's just monitoring of models in production. But anyway, so when it's online, you should still do the offline evaluation. But in this case, it's not so much, again, to benchmark it. Of course, it's to benchmark it against how it was yesterday and the day before and so on, because there are such things as model drift, which means that your optimized hyperparameters might not be optimized any longer after a certain time. That's one of the things that makes machine learning go astray at a certain point. Of course, there is also the data drift that you need to keep an eye on. Then we're not talking so much about evaluation of models, but then you need to keep an eye on your distributions of the data that comes in. And then I just said it wasn't important about benchmarking, but still, of course, you need to ensure that the model doesn't go bad. That's the business side of things before you decide on whether you should put it into A/B testing and so on. On academia, when you get a new paper, it's I think it's very interesting that they come and say, we beat current state of the art. And then you go through a whole day at RecSys, and then you discover that everybody beat current state of the art. And then, so yesterday I took a picture of one of the presentations. That's the picture all the way to the right. And then while I took that picture, I also searched on the internet. And if you look at the last FM MRR at 20, then the picture to the left is a paper from a paper that is some years ago, and the picture to the right is from a paper that was presented here at the conference. And so I've discussed this with a lot of people on the second row the last couple of days. And then the answer is always, but maybe the data filtering, some other things were different. So maybe it's okay, it looks like this. But the thing is that if we want to use these metrics as a baseline and say that it's current state of the art, then it's a number. And it's very easy to say if 0.1 is larger than 0.2 or no. So the question is, if we should use a baseline like this, then we need to be much more precise. And so the value of these evaluations is still, it's a gateway to get into the conferences. And I can see that on Twitter, I wasn't the only one that was thinking a little bit about that. But so if I should come with an idea of what I think we should maybe do differently, is that instead of SOSTA, could we then say that it just needs to work, and then talk about what is it that it needs to work? That will enable us to, I think, get a much more fair picture of how the models that are presented at conferences would actually, how they work and how they perform, because then you don't have these, I don't want to say anything about people cheating, but sometimes you have a filtering of the data that goes into the system before the metrics are printed. So you're sure that everything is going fine. So my suggestion would be, if you, for example, take a data set as last FM that has been used a lot, if we could, the people who published it, if they could also publish it with a framework saying that when you have a model that you want to evaluate with this data set, then use, I don't know, sklearn interface type for your recommender system, and then you just upload it and push a button, and then there will be a leaderboard or something like that, or an official scoreboard. Again, let's keep in mind that I think it's problematic that we keep saying that we have to be better than state of art, because it doesn't really make sense because of different domains and different types of data and so on and so on. But still, then we could say, as long as you reach above some kind of baseline that is better than random, then you should have a candidate article to submit at a conference. And then if you want to do is this that if you look at a physics example or a physics, when you do research in biology or something like that, then you have a data sheet very long that explains exactly what data you used, what time of day, if you had coffee, and all those kind of things. And maybe those kind of things should also be something that is included when you talk about reproducibility of articles, because it's fine with the code, but if you can't recreate the same environment, then it's still easier than have to code it yourself, but it's still problematic that you can actually recreate the same environment. So, okay, I thought there was another slide here. Anyway, so I know that this is probably not something that we can change from one day to another, but I think that it's something that should really be considered, because it's, so I think that we had a lot of interesting articles and presentations the last couple of days, but actually I think that we wasted 3 minutes on basically every presentation on people convincing us that they beat current state of the art somehow, but without us actually understanding whether it was something they did to get it submitted or whether they're actually better than everybody else. Okay, so that was my views on proper use of evaluation. So if you should then forget about evaluation and metrics and so on, then how can we actually measure if a recommender system works or not? I'm still not sure after all these years. We have Netflix, Javier who was at Netflix once wrote the following in a paper, and he says that actually we should not think of a recommender problem as something where we predict ratings. I know nobody really predicts ratings any longer because we don't believe in them, but then we predict whether it should be consumed or not. And there are a lot of other aspects that you should also put into considerations, which is something that is there is a lot of discussion about it, and it's very important. Oh God, am I going backwards now? No. Okay, then there was another paper that somebody made me notice that says that the success of a recommender system is really about how much people trust in it. And for me, that resonates a lot, because basically, I think of the fruit dealer in Rome that I also talk about in my book, that he is the perfect recommender for me, because he knew what I wanted. He knew when I should have stuff and when I shouldn't have stuff. So I like the idea of having relationships. So how do we actually, am I out of time? How's time? Okay, good. And so a relationship is something that requires repeated interactions. And actually, what we really want to do with a recommender system, the relationship between a customer or the consumer and the producer, that could be great if it was a long relationship. And then I'm sorry about my artistic work here, but basically, one of the things that you should consider is that, so a lot of the metrics that we have right now is that we need to make people buy as much as possible right now. But so if what is then more important, is it then if you have on the left side one visit where there was a lot of money spent, or another visit that was little money spent, and then you can say, okay, but if the customer returns and spends a little bit every time, then at end actually we earn more on the customer. So this, you can see that it leads that way. And that kind of leads into something that we talk a lot about, is that we want to maximize customer lifetime value. So basically, of course, we want them to buy a lot also right now, but it's actually more important that they continue buying over time. There are some papers that says that we should be careful being too optimistic, saying that people will always return and so on. So some would say that we have to maximize as much as possible right now, but let's say that we want to be optimistic. And then if we do that, then right now when we look at the data sets that we have, you say, okay, so we have one basket, two baskets, and then we split that data into training data, saying that some is input and then the last item is output. But if we are actually trying to optimize for returning users, how about we then don't look at predicting the next item that will go into the shopping basket or the next movie and so on, and just say, can we optimize the session such that we are sure that people will return? Because then suddenly you kind of elevate the problem to, how can we make this into the best experience for the user right now, so much that they want to return, rather than we sold them a lot of stuff that they probably didn't need. And if we did that, then we could say that we could maybe find, so this is me imagining all the different types of baskets or the different types of best sessions you could have with a user. Then maybe we could find some baskets or sessions that were good, and maybe those ones were clustered in some kind of latent space. Of course, there will also be bad user return patterns, in the sense where if the user experiences this, then they will never go back. And maybe I wanted to give a note here also. And an argument to go towards this one would also be, so people don't like clickbait really a lot. Everybody talks about it. So if we could actually optimize the experience so that they don't look at clickbait, because actually I don't think that if I end up in clickbait, I usually go away from the clickbait side, but I also are careful not to get into the site where there was clickbait in the first place. And so maybe by optimizing for returning users, we will also kind of solve the problem of looking into what is clickbait and not. And then when we have an actual user session, then we could look at the current session and then say, what do we need to happen in that session so we can move it in the direction of a good return state? When I talk about state, it's not that I'm talking about machine learning. That's machine learning, but as reinforcement learning as such, I also think that it's something that you can do a lot on without having reinforcement learning. Okay, those colors look better on my monitor. Anyway, so again, if we consider this to be a latent space where there are kind of clusters of good return states and bad return states, then you could also look at it as distribution, for example, an LDA model or something like that. And then you could use these distributions as a way of sampling what the recommendations should be. Instead of trying to, again, predict product IDs, you could say that my solution should just sample outside of inside this space or this place, and then we could maybe do recommendations like that instead. Yeah. And as an evaluation, I know that this is probably not going to happen, but I think at least it could be a very interesting way of going ahead and looking at recommender systems. Yeah, and this is one of those slides I just added 2 minutes before I had to go up here. So anyway, so the point that I didn't want to forget to make was also that we should remember that when we, again, when I talk about the sampling before and try to do recommendations instead of just the product IDs, I think that that's also something we can translate into to when we do the metrics and the evaluation of models, saying that instead of we have the precision, either it was a recommendation or no, we could say, is it within the vicinity of the item we wanted to predict? Of course, then there are the problems that, again, if you are a browser and you're looking for a t-shirt, then the recommendations are good when they're similar. While if you have an iPhone and you're looking for the right charger, then it has to be the right charger. So the distance or the similarity should also have a threshold based on the model or the domain that you're looking in. And this is, yeah, and sorry, and this is what I just said more or less. And also if we then do the sampling, and when we do the metrics that are not completely the same, but there is an area that is good, then maybe we could also enable more diversity and flexibility into our systems. That was the second part. The third part is that I want to talk a little bit about causality. Because when we talk about recommender systems, we don't often talk about, we talk about whether people clicked or they consumed, but we don't really talk about what happened if they didn't click on it. And so in some work I did at a Swedish furniture company, we thought about how do we do marketing in a good way. And there is this matrix that you can look at, where you can divide people how they will react to some marketing. And I'll just go through them and then maybe talk a little bit about how I think we could also consider that with recommender systems. So you can say that if you look, will people convert if treated, and convert in this case is that they will click on an email or they will react to whatever you send it. And maybe that converted, no, anyway. So the persuadables are the ones that if they didn't receive your marketing, then they would not have done whatever it is you wanted. While since you sent them something, then they will do whatever you are, in a sense that there it was like, if you come to our store, then we will give you a free hot dog if you buy a sofa or something like that. The problem is then, if you talk about the converted ones instead, is the ones that, so we are offering a hot dog or maybe even 10% discount. It depended a little bit on what was at stake. So the hot dog was maybe not the most costly thing. But so we don't want to actually send out marketing or discount to people that are already going to buy the sofa, because then we are losing money. In the sense, of course, they'll be happy with the 10% discount, but they were going anyway. So why should we then take it away? Then there are the indifferent ones, which they're not going to do anything. They don't care. They get lots of those emails anyway, so they just don't interact with it. And then there are the sleeping dogs. And the sleeping dogs are actually something that you should be really careful about, because sleeping dogs are the people that they might go out and buy the sofa, but because that you sent the marketing material, they will say, I don't like this. They are ruining my privacy, so I'll go and buy it at the competition instead. I think that's fair in the sense that I think that I experienced that too. But so again, sorry for the colors. But so basically, what we want to do is when we recommend stuff, we want the persuadables, because in a sense, we have only a little real estate to show recommendations. So why send out recommendations for people who would already buy it? Of course, there is brand identity and so on. So there are still reasons to do it, but you really don't want them to see if yeah, okay. So you really don't want to have the sleeping dogs react to it. And then if you look at it this way, then popular products in most cases will fall into the converted ones, because we don't actually need to send, of course you can say that they're popular because we keep spamming them on people's faces, but actually we don't really need those recommendations. The less popular ones, on the other hand, there is a chance that we can persuade them, but also you should be careful, because here, if it's so bad that they will say that they will never come back, then you have the sleeping dog problem again. So basically, what you can say is that popular products are safe recommendations, because the risk that people how to say, go in and leave and never come back again is pretty small. But also you don't really get any information about it, because what people get out of a popular product, since everybody likes it, you don't get any information back for them. While if you can recommend products that are, how to say, fewer people like, then back to this embedding space where you can say that there is a taste profile and there is things to understand about the users, then the long tail products are actually much better recommendations. So if we go back to the metrics where we talk about we want to optimize our evaluation, then the problem with the way that metrics are done is that it's often the best choice is actually to give the most popular products, because there you have the highest chance of predicting something that is true. But if you look at it as I want to learn more about the users, then actually, I'd say, if we talk about the good return sessions before we want to learn about users and their profiles, then we don't want to give popular products, because that doesn't give us any information. I think that's an important point. And with that, I'm actually finished with my presentation.